Camille the Comet, and after the stringy brown seaweed, we're gonna dive a little bit deeper to have a look at coral reef. Today we're mainly gonna discuss coral reef restoration. So as you can see on the map here, coral reef are mainly located in the southern half of the globe. Indeed, they build up on warm, shallow, clear, and sunny areas along their shorelines. However, despite what the map seems to show, they only cover 0.1% of the ocean's ground. So we tend to see corals as plants or rock, but they're actually colonies of animals. They are polyps. They're soft-bodied animals related to anemones and jellyfish. At their base, the green part of the image here is a limestone skeleton built by the polyps to protect itself. It's known as calicle and made of calcium carbonate. So the coral reef forms when a polyp attaches to a rock and divides into thousands of clones, growing into colonies. Why are they important? First, they constitute a main habitat for marine ecosystem. 4,000 species of fish and 800 species of hard coral rely on it. They're also used as a cure for cancer, arthritis, human bacterial infections, viruses. Also, 500 million people rely on it for food or tourism, and they serve to protect their shorelines as buffers against storms, hurricanes, and floods. So, what is the big deal about coral reef? Here it is. So, Carrisford Reef in Florida, that you've seen here, was known as the most spectacular reef throughout the island chain. The pictures are a series of photos taken during what's known as Duston studies to assess the impact of humans on the reef. Since the beginning of the study in 1974, the reef has declined more than 90%, rapidly reduced to rubble and sand. The physical degradation of reef is accelerated by the process of bleaching. Bleaching happens when corals are stressed by changes such as increased temperature, light, nutrient, acidity, so they expel their symbiotic algae living in their tissue, causing them to turn white, which fragilizes the reef structure. So the worldwide deterioration of reefs, particularly in the last decades, has directed more attention to the prospect of mitigation activities, notably coral reef restoration. It means returning the reef to its previous state, rescuing it, or promoting a given species. So to face these issues, scientists and the civil society have bring their mind together in order to rescue corals or return them to their previous state. One of the most commonly used methods is coral transplantation. Coral transplantation consists in a collection of coral spawn and eggs to grow them into larvae in situ and finally transplant them into damaged areas. The ultimate goal of this technique is to help coral to finally be self-sustaining in the wild. The main benefits of this method are that it allows the survival of locally rare and threatened species and ensures their reproduction, and also allows for an immediate increase in coral recovery. However, this method also have important limitations, such as high mortality rates of transplanted coral, and are still at the experimentation phase. Another method is artificial coral reef, that we'll call as ACR. So corals are grown into nurseries with a method known as coral gardening. This consists in breaking healthy coral branches and growing them into the nursery to finally transplant them into reefs. So ACRs are man-made structures that are recovered by previously grown corals and that mimic characteristics of natural reefs. Some ACRs can be volunteer and man-made, such as Jason Decker's art that you can see here, but it can also be created from a hazard with a shipwreck, for example. So ACR are cost-effective, easy to access, and they help releasing the pressure on existing coral reef. However, dumping man-made material in the ocean doesn't look like a very sustainable method. Indeed, the creation of ACR has the adverse effect of enhancing mass tourism and also giving us free space to dump harmful material in the water. So finally, coral reef restoration methods have rapidly improved over time. However, they are only able to improve coral regrowth on small scale, and a lot of methods are still at the experience phase. So we need further mapping, even though NASA has run great mapping projects which you can easily access on Google Maps. And to conclude with, our ability to mitigate should not restrict protection or better reef management.